Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. This is simpler using machine learning algorithms in R. And so now we're going to go ahead and do our data preparation here. I'm going to try to give you an idea of what our goal and our purpose is as we apply these algorithms in this particular chapter. So let's go ahead and move over to R. So I'm in R, and what we're going to do here is we're going to use something called the math level data set. It's from the Quadratic library. Basically, we're going to try to predict somebody's gender based on the type of classes they took and also some scores on some tests that they took as a university student. So in line 1, we just have the two libraries that we're going to need, packages I guess you can call them as well. The math library has our QDA function in it and also our LDA function for quadratic and linear discriminant analysis, and the Quadratic package or library has our data set. So if we run that, nothing happens. We'll load our data set, math level, that's the name of it. And we'll use the str function to kind of get an idea of what's going on inside it. I guess I can make this a little bit bigger for you for now. Okay, so you can see we have about over 600 samples, if you will, over 8 variables. We're going to use all the variables in this particular one. And so to give you an insight into what the variables are about, we use the question mark and we type in math level. And so let me zoom this in for you so you can get a little bit of a better picture. Okay, so you can see here are our variables, our variables. So SAT is their math score on the SAT. Language proficiency, I believe that's probably a categorical variable. Sex, major, math courses they're taking, how many, 0 to 3, physics courses, chemistry courses. Of course, these are all classes that require a lot of math, obviously physics and chemistry, etc. So that's kind of describing our variables in the set. We also have an ordered factor variable, math level. So obviously, 170, 171A, 172, as you go up, their courses are harder probably. So that's kind of what's happening there. So I can make this a little bit smaller now and focus on the other side of the data. All right, oops, no, I need to deal with the histograms first. Okay, so I just want to make 1 or 2 histograms to give you an idea of, the characteristics of the data. So you can see here for the number of math courses, this is almost like a factor variable, if you almost like that. So a handful of people have not taken any math courses. Most have taken 1 and 2, and then a handful have taken 3. That's kind of what's happening. If you look at the table for math level, you can see here how many people were taking each class, etc. So that's kind of what's happening there. Again, there's not a lot of numerical stuff here. I believe maybe the SAT score, we could do that real quick. So his math level SAT, we could do that. And so these are the SAT scores. Nice, beautiful little bell curve there. But again, not a whole lot of exciting stuff happening here. And so with lines 8, 9, 10, 11 through 12, we're just going to set up our train test split. And then we will be using this data as we make our algorithms. But again, I just want to clarify something that I mentioned in the prior video, but it's so important I want to say it again. You only want to use your test set one time. This is kind of a common tenet of data science machine learning. And so again, I want you to think, you have to kind of assume, because remember, we're just practicing here, that we don't really have a test set here. We have a validation set. Often what is done is that the data is broken into 3 parts. You have your training set where you train your data. You have your validation set, kind of like a pre-test data set, if you will. And then finally you have your testing set. You use your validation set to try to figure out which is the best model to use on the test set. That's kind of what's happening here. So again, sometimes the verbiage is not quite as accurate as we would like, but I just want to make sure that's clear because I don't want to send people out of here, with bad habits. So having said that, the code in lines 9, 10, 11, and 12, we've already seen this several times. We're just rerunning it using the stuff for this context. So we set the seed, we set up our index from 1 to 2, 1 to 2. How many 1 and 2s? For the same number of rows as there are in math level. And 70% of it should be 1s, 30% should be 2s, because we want 70% of our data to be for training and 30% to be for validation, if you will. And so we run that, and then we set up our data sets, math.train, math.test, and we're ready to go. So in this video, all we did was, I exposed you to the data set that we're going to be using, math level. We're going to be trying to predict gender based on the type of math classes they took, their math SAT score, their language proficiency, etc. I explained to you, or we looked at some of the visualizations for some of the variables, and I also tried to clarify the importance of understanding that what we're really doing here is a training, then moving to a validation. We're not really doing testing because when you're using multiple models, remember you only want to use your test data one time. Otherwise, you begin to train your data on the testing data, which is not, you're not supposed to do that. So I hope this video was useful for you and that you were able to understand what we were talking about here. So my name is Darren Thomas. I'm the Director of Educational Research Techniques. This is Simpler, using machine learning algorithms in R. Take care.